Hello class, I'm John Guillot, and I'm going to show you how you can train your own object detection model like the one that you see here that will work on any video source and be able to detect the objects that you want it to. So to do this, we're going to use a framework known as YOLO, or You Only Look Once. Before we can do that though, we're going to need a data set. So for that, I'm using RoboFlow. And if you don't know RoboFlow, I'm about to hook you up. So RoboFlow is a fantastic online library of data sets. For example, if I want to grab this data set right here, I would just go to here, get my download code, like so, copy it, go over to my Jupyter notebook, we paste it in and hit go, and that's going to start the download process and install the dependencies. We end up with a data set that has our test, train, and valid folders, and that is then fed into our YOLO training script. And right here, this is a tip if you're actually using this on like what I'm doing with Google Colab or Jupyter Notebooks. YOLO configures, at least the Ultralytics version, is all configured by a YAML file. So if you're working with the VS Code, then you can simply open that in another window, no problem. But in this case, I generate the YAML file manually with Python in right at runtime. Here we just set our epochs and make sure I'm going to use early stopping because we have a relatively small data set here, so we're likely to overfit if we don't. And as you can see, it's a very minimal set of configuration. YOLO does have a full rich API, so you can configure the model any way you like, but it comes out the box with auto saving, auto stopping, and also a variable learning rate that will help make your models more reliable. Now your data set contains both the images and the binding box and the tag information. So the reason the binding box is so important is remember that you can find more than one object in any given frame, and that object will have the binding box location where that object was found and the class it goes into. So that's where we have to define our classes, our class names, which are pulled out of here, and then stored into a dictionary. Once we start the training process, it's going to show the inner workings of YOLO, which is interesting on its own right. It basically is broken into three parts: a backbone of CPS darknet that gets the edges and the shapes, and then you have a neck that combines those different layers so you can get closer and farther objects at different scales, and then finally the head that gets your binding boxes and predicts your confidence scores for each class. Once our model is trained, we can load it up and use it to make some predictions. For instance, right here, I'm going to run it against a video file. We iterate through it frame by frame, make a prediction, and then superimpose our binding boxes and our labels, and then we're able to generate an output video like what we see here. As you can see, it's detecting trucks and cars and differentiating between them. Even better, since YOLO's become so ubiquitous in the industry, now you have IP camera manufacturers. You can actually load your model directly into the IP camera so you can have it performing on the edge right there using neural processors that are built into the camera. Guys, I hope y'all learned something new. I hope this is something useful, and I hope you're able to build something cool with YOLO.